Okay, so number 43 on page 593, they ask the question, use the discriminant to determine the number of real number solutions for each quadratic equation. Well, notice we're back to the quadratic equation. We've got an equals 0 here. What do you do to find the roots, or the solutions, as they call them? In this case, again, negative b plus or minus square root of b squared minus 4ac all over 2a. You can sing that if you want. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So a squared plus 12a plus 36 equals 0. A equals 1, b equals 12, c equals 36. What's the discriminant? Always get the discriminant. It makes your life easier. Okay, so we figured out the discriminant. B squared minus 4ac is 12 squared minus 4 times 1 times 36, which is 144. 144 minus 144 equals 0, and the square root of 0 equals 0. That means we're going to go plus or minus 0, and plus or minus 0 is the same thing. It gives us one solution. What is that solution? Well, we don't need to know it for this question. This question just asks us to use the discriminant to determine the number of real number solutions for each quadratic equation. The answer is one solution, and that's what you put in a box. They didn't ask you to find out what it is. If you had to, or if you want to, you can find out what that solution is. I'll do it quickly. 12 squared, negative b, okay? Hold on. X equals negative b, which is equal to negative 12, plus or minus square root of b squared minus, which is 12 squared minus 4, 1, 36, all over 2 times 1. We know this whole thing is equal to 0 because we figured it out. Negative 12 plus or minus the square root of 0 all over 2. That means it's going to be negative 12 plus 0 over 2 and negative 12 minus 0 over 2. Those are the same thing. This is equal to negative 6, and this is negative 12 over 2, which is equal to, I'll just write it out, negative 12 over 2, negative 12 over 2, negative 6. Negative 6, it's the same thing. We just write it once, one solution, and that solution is negative 6. Now this question, remember, it didn't ask you to find the solution, didn't ask you to go through all of this, but it's important for you to see why this is one solution. When you get 0 in the discriminant, because the square root of 0 is equal to 0, you get one solution. All right, let's move on. Okay, let's look at page 593, number 47. In this question, it asks you to use the discriminant. In this question, it asks you to use the discriminant to determine whether the graph of each quadratic function intersects the x-axis in 0, 1, or 2 points. I'm going to draw a graph of this so you can see what they're talking about when they say, does it intersect the x-axis? This, now we don't see equals 0, we see f of x equals 3x squared minus 3x plus 4. This stands for a function. The function at the point x. So when we put x into a graph, you know how we used to do this with x and y? Or x and f of x? We put in a number for x and then we got one out for y or f of x. That's what this is all about. And so they're talking about the graph of this quadratic. What will it look like? And in particular, where will the graph touch the x-axis? Where will the x-intercepts be? Well, there's two ways to do it. We could just go ahead and graph this, or we could figure it out by formula. Let's do the formula way first. A equals 3, B equals negative 3, okay, and C equals 4. Put that into the quadratic formula after figuring out the discriminant, and we'll get the nature of the roots. Well, what's the discriminant? B squared minus 4ac. B squared is negative 3 squared minus 4 onto 3c, which is equal to 4. So this is 9 minus, now what's 4 times 3 is 12, and 12 times 4 is 48, and it's negative. So notice this is going to be a negative number. All right, it's going to be negative 39. Now that's something we haven't seen before. What's the square root of a negative number? Not defined. Okay? Not in the real number system anyway. So when we're looking for the roots, the solutions we know that there are no solutions, no solution. Therefore, there are no roots, no solution. And when we answer this question up above, where it says, use the discriminant to find out whether the graph of each quadratic function intersects the x-axis in 0, 1, or 2 points. Well, it doesn't intersect the x-axis, and therefore the answer is 0. 0 points. Okay? In 0 points. Right, now to understand that more fully, let's look at the quadratic formula. X equals negative negative 3, negative b, plus or minus the square root of b squared minus 4ac, which is negative 39, because we figured out the discriminant, all over 2 times 3. And again, no matter what this other stuff is, it's 3 plus or minus something that's not defined. So that's all you have to do. It's all you have to know. No solutions. Okay? Or the empty set. 0 points. It does not intersect the x-axis. Let's look at a graph to see what kind of function we get and to see what they mean. What will this look like when they say it doesn't intersect in any points? Well, when we graph something like this, okay, we use x and we got out y. In this case, we call y f of x. In other words, the value of the function at x. If we put in 0 for x, well, what do we mean by put in? We're putting 0 in, okay? Okay, we put in 0 for x, we get 3 times 0 squared minus 3 times 0 plus 4 is equal to 0 minus 0 plus 4, which equals 4. So we put in 4 for f of x. When we put in 1, we get 3 times 1 minus 3 times 1 plus 4 equals 0 plus 4, which is equal to 4. So we got 4. F of x is equal to 4 in both cases, when we use 0 and 1. What happens when we use negative 1? We put in 3 times negative 1. So this is 3 times negative 1 squared minus 3 times negative 1 plus 4. 3 times negative 1 squared is equal to 1. So we get 3 plus 3 is 6 equals 10. We put that in here. We're going to see in a moment when we graph this, this is going to start to make sense. We'll see what kind of shape we get. And many of these quadratic formulas give you a certain type of shape. It's called a parabola. 3 times 2 squared equals 2 squared is 4. That's going to be 3 times 4. And this is 12 minus 6 plus 4, which is 6 plus 4 equals 10. Again, we get 10. Now we're going to go ahead and graph this. Let's see what it looks like. So 0 and 4, 0 up 4, 1, 3, 4. That's one of the points on our graph. 1 for x and up 4. There we go. That's another point. And let's see about this. We've got negative 1 and 10. So we go over 1, up 10. And we've got a point right there. We've got positive 2, 10, go over 2, and up 10. We actually have a shape forming here. This is a parabola. Goes through here, and somewhere right around here it's going to loop up. It's called the vertex, and give us a parabola. And so this is a parabola. This is called the vertex. This vertex right here, all right, corresponds to, it looks like between 0 and 1. And guess what? When we put in a half here, all right, we get 3 times 1/2 squared, 3 times 1/4, minus 3 over 2. I'll get 3/4 minus 1.5. Negative 3/4 plus 4 is equal to 3 1/4. And if you look on our graph, it's kind of hard, didn't leave enough space, but basically at the point 1/2, 3 1/4, we're going to have our vertex somewhere in here. That's at the bottom of the parabola. You can see that this parabola doesn't touch the x-axis. So there's going to be no x-intercepts, and therefore no roots, no solutions. And that corresponds to the fact that the discriminant gave us no solutions. So that's the reason for it.